Okay, so I think that's pretty much 6:30 in my local time zone, or 5:30 in UTC. So this is our penultimate session, everyone. I hope you're still with us. I hope your minds are not too melty. We are here with Aaron, Taryn, and Andy with Lesson Learned at Stack Overflow, Availability Groups at Scale. Take it away, folks.
Hi, everyone. I'm Taryn Pratt. I will kick us off. Welcome to our session about availability groups at Stack Overflow. Andy, Malin, and Aaron Bertrand are also here. They will introduce themselves in a second. But first, again, I'm Taryn. So I used to work at Stack Overflow. Right now, I'm a senior PM at Microsoft. I also love pivots. If you know that, you probably follow me and know that I love pivots. And my pronouns are she, her.
I am Andy Malin. I am a staff DBRE at Stack Overflow. My pronouns are he, him. I've been a Microsoft Dev Platform MVP since 2017. So 6 award years, but 5 years on the calendar. And I'm super lazy and impatient, and that helps me be good at my job.
Yes, especially impatient.
Yeah. Go ahead, Aaron.
Yeah, so I'm Aaron. I'm also staff DBRE at Stack Overflow. I've been an MVP for, I'm not going to put the year down. I'll just say I've been awarded 25 times. And I'm an old Canuck with many opinions, and my pronouns are he, him.
Okay, so quick overview of what we're going to be covering today. So obviously, availability groups, Stack Overflow. I'm going to go in a little bit on the architecture that we have. Aaron's going to cover how Stack does observability and performance, and Andy's going to get a deep dive into scalability problems. And hopefully, if we have time at the end, we're going to have an Ask Us Anything about Stack. So architecture and why we built and how and why we built it. So first up, I have to start with a disclaimer for all three of us. None of us were around when any of this was built. So many of the decisions that were made at Stack were inherited by all of us. I left it to Andy and Aaron to kind of take it over when I left, but I inherited it and I worked on it for a very long time, trying to make it as stable as possible. And even though I've been gone for almost a year, I still know the infrastructure very much like the back of my hand. But the big caveat that I have to say is that the architecture and setup that Stack has worked for our needs at the time. It does not necessarily mean that that will work for you. The problems that Stack was trying to solve were very unique to Stack. So that is something that you have to keep in mind when looking at our architecture. So the Stack architecture is very different than a lot of other places. It launched in 2008, and we were always very hardware constrained. What I mean by that is we didn't have a lot of money, so we didn't have a lot of infrastructure. So we had to make do with very limited infrastructure for our on-prem layout. It's very much still an on-prem organization, as Andy and Aaron know, and they still very much run on very limited hardware. Limited hardware, but it's very beefy. So when I say beefy, the Stack Overflow server has 1.5 terabytes of RAM. And while we were restricted to limited hardware, the goal always was to be as efficient as possible across the entire platform. So Stack is outside of the Stack Overflow database. There's always where it was built as a multi-tenancy architecture. So what that means is each one of the sites across the entire network has its own database. And that pattern of a multi-tenancy continues for Stack Overflow for teams where there's thousands of schemas, one per customer in each database instead of thousands of databases, because Andy and Aaron would definitely not want to be maintaining thousands of databases. The one thing that I do have to stress is that Stack Overflow always has said that performance is a feature of the site. I know that I drilled that into Andy, and I assume he probably drilled that into Aaron when Aaron started. Performance is a feature. And what I mean by that is that The goal has always been to load the site as fast as possible with very little latency across the board. So like, for example, if you Google Stack, any type of question or anything like that that pops up on Google, that points to the question show page within the architecture, and that's actually querying the database directly. So that's not cached. We want you to be in and out as soon as possible across the board for any of those questions. So performance has always been a feature of Stack. Overall, the architecture of Stack Overflow is very simple. There's not a whole lot to it because we didn't have a whole lot of hardware. So we have there are two data centers for Stack. The main data center is in New York. Technically, it's New Jersey, but we never wanted to change the names of servers. And the DR site is in Colorado. The infrastructure is basically, there's 9 web servers. They use Redis for some caching, Elastic for search. And then there's 4 SQL servers basically that handle all of the public facing sites outside of Teams. We're not talking about Teams for this. So within the public facing sites, I'm talking about Stack Overflow and then the Stack Exchange network of sites. And each one of those clusters it's a 3-node cluster. We've got a primary and a secondary in the New York data center. And then we have basically the same infrastructure, obviously, in our DR site in Colorado. So it's a very, very simple layout and very simple architecture that we have when it comes to infrastructure. And that goes hand in hand with the fact that we didn't have money. So Stack didn't have a lot of money, so they didn't have a lot of infrastructure. So now when we start looking at the SQL Server side of things, this is a very high level, very basic layout of how SQL has been or was when I was part of the team. There are 2 main clusters. There's a Stack Overflow cluster and a Stack Exchange cluster that handle all of, as I mentioned, all the public facing sites. They are both 3-node clusters, 2 in New York and 1 in Colorado. We also have an additional cluster, which is an internal dev cluster. Again, 3 nodes. Those are on VMs, though. Those are not physical hardware. And then there's it says channels cluster. Channels is the Stack Overflow for Teams product. They initially were called channels. Again, we didn't want to change the architecture and change the names, so everything says channels, even though it's actually Teams, but that's a whole nother story. So in this overview, you can see that we have Stack Overflow cluster, Stack Exchange cluster. These are, as I mentioned, they're 3-node clusters, and we use availability groups for them. So the Stack Overflow cluster, there's only 5 databases. That's where the beefy guy, Stack Overflow, exists. So there's 1 availability group. On the Stack Exchange cluster, there are 4 AGs, 388 databases. One of those AGs has 375 databases in it, or had 375 databases in it when I was there. And then you'll notice that we have these lovely red arrows where it has SODAG, HADAG, INTDAG. So basically, across the infrastructure, outside of using always on availability groups, we also use distributed availability groups. So what we do is on the Stack Overflow cluster, there is an AG, but there's also a distributed AG that ports basically and replicates the data from the Stack Overflow cluster down to our reporting cluster. I'm going to use reporting in quotes because it's like a rudimentary data warehouse. So the reporting cluster gives the internal teams and engineers the ability to query the primary and query live data in the databases without taking down production, hopefully. That's the goal. So across the board, we have multiple AGs, and then we have distributed AGs that all point down to the reporting cluster. And for that cluster, there's 2 servers. There's 1 in New York and 1 in Colorado. Outside of those, Stack also has a whole bunch of miscellaneous servers that include like log servers, dev, test, a bunch of other stuff. So that's the very basic overview of the Stack Overflow infrastructure. So one of the things that is the most important thing about to remember and realize about Stack is that while we had limited hardware, And there's perks to that because there's less patching. There's less things that you have to worry about, especially when you're in on-prem and you've got to patch stuff. There's a lot of challenges that come with having limited hardware. The main thing is, like, you really have to know your infrastructure. Like, you have to know it really well. I had to always be mindful of free space. When I first started working on the SQL servers, we were at like 90 to 95% full. So there was a lot of juggling of data. There was even some shrinking that would take place on the databases because you have to make do with what you have. And so that's a challenge that you can have when you have limited hardware. Patching and upgrades can be really, really difficult when you don't have a lot of hardware, because when you only have like a 3-node cluster, let me go back here real fast. When you've got 3 nodes in a cluster, and you've got a primary and a secondary, and you are gonna you need to patch the primary, and you fail over to a secondary, you've got all of your traffic going to one server. So things that you have to consider is you've got to consider user connections and the load and all of that stuff when you are patching. And when you start talking about upgrades and you have distributed AGs, that adds some additional complexity, because when you switch versions, you've got servers that are not going to work when you have limited hardware because you've changed versions and things like that. So some of the things that I would really stress as across any kind of environment is monitoring, and knowing your environment is incredibly critical to making sure that you are successful and you can keep your servers up and running. And I am going to now kick it over to Aaron.
You're such a fast talker, Taryn.
I know. I'm sorry.
No complaints. Aaron's going to talk for like 25 minutes.
No.
I knew that you both would kind of pick it up and like would fill it in, so.
Yeah. All right. So as far as observability go and performance go, basically the question is, how do we keep the lights on? How do we make sure that our database servers are performing well, that the application is performing well? And so from a DBRE perspective, we have a lot of observability tools. And there we go. And the first one that we use is Opserver. This is an open source tool. It's at github.com/opserver. And we use it for a variety of things. High level and detailed resource usage. We look at the availability groups, their current configuration and their status for some of the other services like Redis. And then it also has a nice summarized top and active queries view. And we can also look at exceptions from various servers there as well. And why do we use that instead of built-in tools? It's a much more concise view than SSMS or SQL Sentry for AG specifically. And some of the top query stuff too is very powerful to see aggregates. And I'll show a couple of screenshots from those. So at a high level, we can look at all the database servers and the web servers, and we can see what's their CPU, what's their CPU been like over the past hour, what is the memory usage, what kind of network are they using, what kind of disk are they using. Very high level view. But if something is performing very poorly, it's going to stand out here very obviously if it's very different from the others or very different from its pattern over the last hour. The AG view I love because it's all of our AGs are on one screen, so we can see instead of like going through dashboard after dashboard after dashboard in SSMS or all of these views inside of SQL Sentry, we've got one screen where we can see the status of every single AG, every cluster, every node in each AG, and see what the latency and the rates, log send rates and everything else are all visible right here. We can see how many connections are on each server, what the status of all of the databases are, and all of that. And then the top query view can show us aggregated view of all the queries that are running, which is very different from what you would see in Query Store or SQL Sentry or any other monitoring tools. just because it aggregates all of these things. How many times are these queries running? What is their average runtime? What was the last time it was executed? Much better view than things where if you're failing over and your databases, you go from a primary to a secondary and then back again, you lose a lot of this information with the built-in things like Query Store. We use Andy's DBA database for a lot of things. Mostly for me, it's for availability group latency. It's the one store procedure in there that saves me the most amount of work because I am way too lazy to memorize joins like this. I don't ever want to have to write this from scratch. There's a store procedure in there. You just say check AG latency, and boom, you get all of this written for you. Very powerful database. A lot of other useful stuff in there too, so I highly recommend checking it out. Whether using AGs or not, this is just one of the aspects. But we were also using it yesterday to look at how much free space was left in one of our log server databases. We've got multiple file groups and multiple files in those file groups. And instead of going and trying to figure out what are all these joins between sys.partitions and sys.file groups and sys.data spaces, that just already does it all for you and gives you what is the size of each one, how much free space is there, and all of that. We use SQL Sentry, and not just because I worked there for 9 years. It has very fine-tuned alerting, so you can really set up how you want to be alerted on things that you want to be actionable versus non-actionable, and it's very good for post-incident analysis. So for Observer, you can see what's going on right now. Right, most of the things are just real-time view. You can't go back in time. With SQL Sentry, we can go back and say, what was this thing that happened for half an hour yesterday at lunch? And it allows you to go back and see those things that happened and correlate everything together. It's got a great dashboard. It's highly configurable, a lot of drill through. Downside, some features are not supported. So we can't look at distributed availability groups, for example, it doesn't support it. And actually, when you try to load the availability group screen right now, it crashes. So not the best experience for that specific observability. But this is just an example of the dashboard. So if I see something, a minor CPU spike yesterday at 5:30, I can click and drag on that chart to jump to, and I can go look at the top SQL statements that we're running or other things. We also use single effects. We use Splunk to feed all kinds of metrics and our own custom homegrown things to feed metrics into signal effects. This is mostly for hardware and OS. Or for our team anyway, we look at the hardware and OS level metrics like storage and network. We have some app specific dashboards like how many teams are active, how many teams have been created. So certain teams have specific things in there. And why do we use this tool? Well, the dashboards are easy to configure. And this wasn't something that we enabled for DBREs. This is something that's used by other teams across the company that don't have anything to do with databases, right? So it's just something that is a bunch of metrics are being fed in there, and it can be a useful place to check for certain things during certain incidents. And it's just an example. See, when we look at this for a SQL server in our environment, it's pretty boring because there's nothing. I mean, you typically don't have any of the kinds of spikes that you see in other application level metrics. We have some other internal data and tools. We have HA proxy logs. This is the place where we store all of the traffic that's coming in to the network. And it really enables us to investigate things like site instability issues that you might have seen us managing in the last week or so. We go through and try to slice and dice and figure out what IP ranges are these queries coming from, and what routes are they hitting, and why are they taking longer than they usually do. And it's a lot of data, and it's not very fast, but it allows us to really hone in on something that just happened and see what are all the patterns for that traffic. Datadog. So we are currently in a POC for Datadog. We're taking a look at that, and this is primarily to reduce observability sprawl. I don't want to talk about our observability in 5 or 6 slides. I want to talk about it in 1 slide. So ideally, we eventually like to get onto one tool. I don't know how fast that'll happen, but this tool is already paying off. It already pointed out an imbalance we had on a load balancer. We had a load balancer sending requests to 9 web servers, and it immediately, as soon as we turned it on, it pointed out, hey, this this load balancer is not distributing the load evenly across these servers. So it's already had one little positive impact. And so one of the things that we want to do in an effort to keep this as a performance as a feature network of sites is to minimize database load, right? We don't want the database to ever be the bottleneck, and we want to deflect the blame from the database as often as we can. Because usually it's not, but you still have to make an effort to get there. That doesn't just happen automatically. So some of the things we do to minimize database load, we use readable secondaries for a lot of read-only queries, right? And for other activity like backups. So sometimes the readable secondaries, people think, oh, well, let's just throw all the read activity at the secondary. Well, that only works to a point because that secondary has the same kind of limited resources as the primary. Typically, they're similar to the primary. And you can't just say, well, throw 8 billion read queries at the secondary. It'll be fine. Nothing bad will happen. A lot of the things that you do on your secondary affect the primary, and they affect the network, and they affect the response time of the app. So something you do have to be mindful of. It's not just your TempDB porta potty of your cluster, right? Sending all the traffic there. We use Redis, so mostly for best effort read caching. So things like lists. So you have a list of questions that belong to a tag, let's say. And so that's a good place to cache things like lists. Not a good place for large content like a post, right? So this is, Taryn mentioned earlier, when you go and you request to see a question with its answers, that goes to the database, not to cache, because if you think about how many questions there are on Stack Overflow alone, and then across the entire network, your Redis instance would have to be bigger than your database in order to always have a cache in. So most of the time you're going to have a miss if you're trying to pull a question from Redis. And because questions, especially when they're brand new, are edited and metrics about them change constantly in the first day or for the first certain amount of time, like you would be constantly flushing those into Redis to make sure that the cached version is the one that everyone sees, right? Is up to date with the one that is actually in the database. So all of that flushing just doesn't make sense to use that as a cache for large content. Sometimes we use it to offload writes. So one example is we have, when you go to post a question and you start typing, you might notice that if you close your window and you come back, you still have a draft there. That's written to Redis, and it holds that in the Redis cache instead of writing that draft to the database. So you'll also notice that sometimes if you wait too long and you come back, it's gone. So it's not a permanent thing. So that's just one way we offload writes. Instead of saving that draft to the database, we save it there. We use Elastic for searches, and the primary reason for that is that we don't want all of the searches that users are running all of the time to go against the database. We can't use a product or a feature like full text search. You can't solve most of the searches that our users are running because they're searching for things that are inside of code or certain keywords that aren't really words or segments of words. And we have all kinds of custom filters like, is it a question? Does it have an answer yet? Does it have an accepted answer yet? All of these things. And then we have a CDN, we have HA proxy. So we have these things at the outer layer that can offload some of the requests that even come into the application, never mind the database. So we cache, I don't know, one of the things we were talking about today was favicon. So we have a favicon at the top of the thing. That doesn't have to come in from the application. That can be something we can cache out at the outer layer. And the request never comes into our network, things like that. So if we think about the layout that Taryn was describing earlier, we've got 9 web servers out here. We've got the Redis and Elastic nodes. We've got the primary and secondary databases. Most of the read-write or most of the write activity goes directly to the primary. We can't write anywhere else, except for the minor example I was talking about with putting drafts into Redis. All of the reads, we try to get all of the reads or most of the read activity coming from the secondary, so we're not interrupting and having impact on the primary. So these come from Redis, Elastic, and the secondary. We also offload some of our internal analysis to additional copies of the data. So something I didn't put on the slide is SETI. So we have a Stack Exchange Data Explorer. That's those queries that you see run across an anonymized separate copy of all of the network databases. So we have those, we put those copies of those and refresh them every week. Yeah, every week. And those have copies of the data that end users can go and run analytic queries against, and it doesn't impact our main site production workload because it's a separate copy that's just for that purpose. We also have things where internally we're using sources like Snowflake. We use Snowflake to perform some of the analytics against our data so that the teams that are performing those analytics also aren't impacting our production workloads. This is one of the trade-offs we make. So we currently use async secondaries just to avoid the penalty of waiting for the acknowledgement, right? So async secondary has a slightly different behavior, and performance is a feature. So we want to make sure the page load for something, or not the page load, but something that the user does that ends up having to write to the database, they shouldn't have to wait for the acknowledgement from the secondary for that write to happen and for them to the page to return to the normal behavior. So we kind of trade safety, a tiny little bit of safety there to reduce latency that the user experiences. Some other best practices we violate. This isn't really performance related so much. We have several of our applications have no schema prefix. So all of the queries say select columns from posts. There's no, if you ever see in any of our incidents, we show a query that is run, or even the sample queries that we put on SETI, select from posts, not from dbo.posts, because part of our architecture is made to support multiple tenants inside the same database. So we have every team, let's say, has their own schema. So when they come in and they authenticate as their schema, they're in their default schema, team 1, 2, 3, 4, 5. And when they say select from posts, they get select from team 1, 2, 3, 4, 5.posts, which is fantastic for not having to have a separate query for every team, right? So every team gets to reuse the same code. So when you fix a query, you add a semicolon to the end because it was never there, or you change some logic in it. You don't have to change it for all of the teams that we have and all of the networks we have. You deploy that same changed piece of code, and it works again. It continues to work against all of the databases because of the authentication. The downside is that now if you have 10,000 teams on a server and they all run the same query, you have 10,000 copies of that plan in the cache because each one is associated with that schema. So that's a downside we kind of have to pay attention to. Stored procedures. So this was kind of a little pet project of mine when I started. It's like, we don't use stored procedures. This is really bad because it reduces visibility and control for us. If we want to help tune a query, we have to first catch exactly the query that was sent because the application is constructing the query. And it's really hard for us to go into the C# code and figure out what is the actual query that gets created in this scenario because it's all constructed dynamically. We use Dapper as an ORM, and yeah, I feel like if we spot a situation in a query that's come across and we want to help tune it, our hands are kind of tied, right? We have to go back to the development team and say, hey, this query that comes from this page, this line in this file, it does this, and we need to add this hint, or we need to change this join criteria to this, or change the way the data type that this parameter is passing. And this is something that's been here since before Stack existed. So Jeff Atwood wrote the store procedure a long time ago. Who needs store procedures anyway? And that's kind of been the Bible since then, and will continue to be the Bible since then. So kind of I don't know, it's a bittersweet thing because on the one hand, I want to have store procedures because I want to be able to have that visibility and be able to solve the problem instead of just having to talk to an engineer about how they can solve the problem when it's clearly a query or a database or some kind of tuning issue. on our side. But on the other hand, can't argue with results. So they have spent a decade optimizing the code to minimize page load times, and it works, right? The entire web app for all the networks runs on 9 web servers, right? When it's active in New York, when it's active in Colorado, 9 web servers, which is kind of amazing when you think about the volume, right? These web servers are consistently at less than 10% CPU. They use about 30 to 35 gigs of memory on a regular basis. Page renders, 20 milliseconds. That's without caching. That's what Taryn was talking about. You read a question, you open a question page, and it pulls the question and the comments and the answers and the reputation and the users, all the users that were involved. That page renders in 20 milliseconds. How am I going to argue? How am I going to fight for stored procedures, right? Like, I'm going to say, hey, I could make that 18 milliseconds if you change all of your entire development model and introduce stored procedures, and I'm going to save you 2 milliseconds per page render. They're going to tell me where to go. Like, it's not enough. There's no ROI there for fighting to change the way that we currently do things until it becomes enough of a problem where we have to, right? When that goes to 50 milliseconds, am I going to have an argument? When it goes to 200 milliseconds, am I going to have an argument? And at some point I will, I'm sure, but it's not right now. We serve 6,000 requests a second, 2 billion page views a month, 2 billion page views a month with no store procedures. And all of those page renders of question and answer pages, again, no caching for those. All of the public network sites run on 2 primary SQL Server instances, right? Technically 4 because they get the read activity from the secondaries, but all of the write activity, which is a lot of it, is on 2 servers, 2 SQL servers. Those are consistently at less than 15% CPU, but they do use all of their memory. That is not a question. So if you think about this setup, right? 9 web servers with 96 gigs of RAM, 2 Redis instances and 2 Elastic instances with 32 gigs of RAM each, and then secondaries or primaries and secondaries with 1.5 terabytes and 768 gigs of memory. And that's 2 billion page views a month at 20 milliseconds per render, which is that number just blows me away. I work here and I just think it's phenomenal. So the performance problems that we do chase, sometimes we find a pattern, right? We're usually finding classes of problems, not this query is bad, but the way that we're approaching how we're getting the data for this query and whether we can pre-aggregate it up front instead of getting it in real time every time. Those are the kinds of classes of problems that we're constantly chasing. But a lot of them are just not related to end users, right? Or the application. And a lot of times not even related to the volume. They're just things that aren't working the way we expect. So currently we have a problem with our failovers. And the way that we deal with this is under normal operation, we have read-write activity that goes to the New York web servers, and then they interact with the services that are in that data center, right? So you have these 9 web servers in New York, and they talk to Redis and Elastic and the primary and the secondary in New York. This is the way things normally operate. So during patching, what we could do is we could just point the New York web servers to Colorado, right? So we could do our failovers inside of New York, and the New York web servers could just talk to the services in Colorado and the databases in Colorado. So that would look like this, right? The databases, we pretend they don't exist, and we send all the traffic to the databases in Colorado. Instead, we fail over the entire architecture. So we have DNS and proxy out front that sends the requests. Instead of going to the New York web servers, they go to 9 web servers that are sitting in Colorado that are specifically designed to handle the workload, just like if the New York data center exploded or flooded or whatever, right? Pretend the New York data center doesn't exist. We have to mimic the architecture there so that the site can stay up even if a data center is gone, right? So what happens there is DNS sends requests to the Colorado web servers, and the entire site changes mode to read only. So now in Colorado, they read from the Colorado replica, or from Redis and Elastic, but they don't do any writes, and the application just prevents any writes from happening. So that kind of looks like this, right? So this kind of pretends that New York doesn't exist. The reason we have to do this is what Andy's going to talk about next, and he's going to explain how many databases fit in an AG.
Thanks, Aaron. Do you want to stop sharing so I can share my screen?
Yeah, as soon as I.
The other things that so we use the failover to Colorado for any maintenance window. So that includes we were doing network maintenance last year where we were replacing all of our network hardware. So we were able to run completely out of the Colorado data center while we did that, take down the New York hardware, replace it, and then move back to New York later. And it was a really smooth maintenance window. And most people didn't realize that there was a period of time where we had zero network connectivity in our New York data center. But we're here to talk about how many databases fit in an AG. So I'm going to start by script. I'm trying to hit my buttons while I'm on the presentation instead of being like on the Zoom instead of being on my actual computer. Where did PowerPoint go? Where's my slideshow? I swear I'm a professional. I've done this before. My slideshow, it won't let me switch to my slideshow. Okay, I'm having the same problem Aaron did. Let me stop my share. Go back to my slides. There we go. Share.
So we've got a question while you're sorting that.
Yeah, while I'm being incompetent with PowerPoint.
No, PowerPoint's really frustrating. Says when you fail over to Colorado, is the Colorado SQL server a single point of failure? Should you have two Colorado SQL servers?
So I will go ahead and say that there's not really a need to have two servers there. If we were planning on running in Colorado for an extended period of time, we might need high availability, but we don't plan for cascading failures. Cascading failures being not only is New York unavailable and we have to move to Colorado, but also something happens in Colorado at that exact same time. And it's an ROI thing. It'll change for different businesses. For some people, it will be, whoops, now it's working. For some people, the ROI means that you do need to have high availability in your second data center. When I worked at Wayfair, all of our storefront database servers had 2 nodes per geography. But for Stack, that's just not in the ROI for us. It would be really common for e-commerce or healthcare or some other things. Go ahead, Aaron.
The difference is, like for e-commerce, that's a cash register, right? And you need the cash register to always be available. But for a lot of sites, I think that having a secondary in your DR site is like carrying 4 spare tires on your car, expecting that either all 4 tires are going to blow out, or you're going to blow out the same tire more than once on any given trip. So it's kind of like, is it worth having that extra redundancy just in case multiple things happen?
Can I just chime in and say, I know that we did have an extensive discussion about this probably a year ago about adding another node in Colorado because there was going to be a massive hardware change that was going to happen in New York, and New York was going to be taken down for a while. So we were going to be running out of Colorado solely off of one server, and all the red flags went up. Like, I don't know if we can do this. Like, we don't know if we can successfully run off of a single server for a week. So the SRE team worked very hard and very diligently to make it so that it was possible for them to do the upgrades that they needed to in New York while still running out of New York with just maybe some read-only time out of Colorado, because buying additional hardware when you're on-prem is very expensive. And as Alan said in chat, like there's licensing costs that come along with that if you add additional hardware. So, and as I mentioned, the hardware is beefy. So it's going to be expensive to license an additional server that's just going to sit there most of the time. So, yeah.
Cool. Good question. Excellent question. So now I'll go into this. Before we talk about problems, what actually happens when you fail over an AG? So there's two parts of it. Transitioning from primary to secondary. So the server that is your initial primary stops allowing writes. It has to perform the rollback or roll forward for things that are in flight at that time. So for most things, if there's a transaction that is open at the time of failover, it has to roll that back because the partial transaction won't be finished. And it also has to begin accepting logs from the new primary, and then everything is all turned around. On the server that is the initially secondary and becomes primary at the end, it has to make sure that all of the transaction logs that have been received are completely redone, and then it can begin taking transactions, including writes. And usually this whole thing takes less than a minute or so, depending on how many databases you have, how busy they are, and a bunch of other factors. So let's take a look at what failing over an availability group looks like if you've got 380 databases in it. So Aaron mentioned we typically run pretty low on our CPU utilization. So I'm going to make them nice round numbers and say that we're running at about 20% CPU utilization on the primary node and 10% on the secondary node. And when we fail over 380 databases, you'll see here in this graph, CPU spikes to 100% very quickly. Instead of being finished in a minute, CPU is at 100%. And then a couple minutes later, the CPU on the former primary, that initial primary, drops back down. Sigh of relief. But the new primary is still pegged at 100%. Okay, a couple more minutes, and now the new primary has settled down to about where we expect it to be. Oh no, the former primary is back at 100%. Now, the first time I did a failover after I joined Stack, Taryn had already experienced this. So she was like, buckle up, Buttercup. This is going to be a ride. And she told me what was going to happen. I still wasn't prepared for the anxiety of watching a server where your CPU graph looks like this. Now, some people might be thinking, okay, but the new primary seems to be healthy during this time. And it is, it is. But what about all of those read-only connections? What about non-availability databases on the other node? Taryn mentioned we run multiple availability groups on these servers. The other availability groups, if they are still running on the SQL 03 in this graph, that server's at 100% CPU, and there is no way any of those other databases on that node are going to be able to do any work. This is really important. It also ties into something Aaron mentioned along the lines of we use async mode for the AG because we don't allow automatic failover. If we allowed automatic failover and one AG failed over, we would be screwed because the former primary CPU is going to be all over the place and we're going to have sites down. We're going to have stuff not working when CPU is at 100%. So during the maintenance window, when we do a failover, this is where we have time to chit chat, take our anxiety medications because our anxiety is through the roof, pop a Xanax, whatever. After about 45 minutes, the CPU comes down. Now, why does it do this? It's terrifying to sit there and watch it. So we started having this after we upgraded to SQL Server 2019. It was not a problem when we were running on 2017. This is important if you're currently running on an AG that is 2017 or below with a lot of databases in your AG. Make sure you do as much testing as possible to figure this out, because you may run into the same issue. But I will also say this has been difficult for us to reproduce outside of our production environment. And Microsoft hasn't identified a specific change in the versions that is responsible for this. We had a support case for an extended period of time. We did a lot of trace captures, lots of different levels, iterated on that a bunch of times, and we weren't able to identify what exactly was causing it. Or rather, what change was causing it. We know what was happening when the former primary goes through recovery in order to set the databases into secondary mode, and it has to do that roll forward, roll back. It does a lot of work simultaneously, and that leads to thread exhaustion. Even when the databases are not particularly busy, even when the databases are not particularly large. So, and you can see that the server runs with great CPU utilization all the time. I think we can all agree that 20% CPU utilization is fairly low on a server. I wouldn't consider it high until you get above 50% or higher, even higher than that. But still, even though we're using servers able to do business as usual at 20%, doing the simultaneous recovery on all of those databases sends the server to 100% CPU. So we thought about what we can do to make recovery faster. We went through, we verified that we didn't have any databases with crazy high number of VLFs. Having to scan a lot of VLFs can cause recovery to take longer. It can cause your failovers to take longer. We ensured that indirect checkpoint was enabled on all of those servers so that they're checkpointing as often as possible. Checkpointing pushes changes to disk, gets them out of memory, and just makes sure that everything is ready. That also ensures that failover is fast. We also tried doing manual checkpoints along the way, doing a manual checkpoint before failovers. We enabled accelerated database recovery, which is a new feature in 2019, to make, which is, and the name says it all, accelerated database recovery. We want to make recovery faster, so we enabled accelerated database recovery. Aaron wrote about that. We saw some benefits on our backups being much faster after we did all of this work, but none of it affected our failover time. So at the end, we could add more CPUs, right? Add more cores. CPU hits 100%, add more cores, throw hardware at the problem. But we're running on physical boxes. So if we want to add cores, we have to buy new servers. And as mentioned, that's really, really expensive to buy matching ones, 3 new servers, to make them super beefy. And CPU utilization is fairly low all the rest of the time. 360 days out of the year, CPU is low. It's only when we're doing failovers that we're having a problem. So it seems silly to spend all that money on hardware for something that happens 4 or 5 times a year. This also came up already, but SQL Server Enterprise Edition licensing is not cheap. So in addition to spending all that money on hardware, now we have to spend additional money on licensing. Again, for 5 days a year, and the other 360 days, that money is going to be wasted. So this is when we came to the conclusion that our next step was to break up the AG. we're going to take that big, huge AG and just break it into smaller AGs. Thankfully, this is actually not as hard as it seems. So after you get the AG itself created, so I'm leaving out here the fact that you have to create a new AG. There's domain objects and permissions and stuff that goes along with that. Let's forget about all that stuff. But when you go to move a database, it's actually fairly easy. You pause log backups just so that they don't get in the way. You remove the database from the availability group. You do that on primary as stuff flushes across to the secondary server and everything gets redone. So it basically drains the send queue and the redo queue. Now the database will flip from secondary to in recovery. After it does that, you run a new command on primary to add the database to the second AG, and then do the join on the secondary server. You do not have to restore a log backup. You don't have to do any sort of reinitialization. No, so even if the database is large, this process will be quick. It's only going to take as much time as it takes for your send and redo queue to flush. So if it's a busy database where you're sending a lot of changes across, then that wait at number 3 might take a little bit longer. But it doesn't matter the size. It's not a size of data operation. A lot of people think that you would need to restore on secondary, and you absolutely don't. And then the last part is we need to repeat this 380 times, which is not great. I don't want to sit at my computer for weeks saying alter availability group, remove database, alter availability group, add database. I'm going to go insane. So Patrick, one of our teammates, he wrote a PowerShell wrapper that does these 6 steps, and you pass in a list of database names, and it pauses log backups for those databases, does the swap to move it to the new place, and then resumes log backups at the end. It'll take a few hours to move 60 databases from one AG to a new one, but it's very little work. We were breaking them up into groups of, I forget what we picked, 6 or 10, some smallish chunk to do it so that if the script, if we ran into any problems, we wouldn't have like a script that's running for 4 hours. But it's worked pretty great. So the question that I asked at the start, how many databases fit in an AG? If you read the docs, it says that the number of databases you can have in an AG is unlimited. Now, an instance has a limit of 32,767 databases. So that means that any AG can have up to 32,767 databases in it. Microsoft recommends that you don't put more than 100 databases into an AG, but there's no enforcement for that. Their test cases are built around 100 databases. I believe I read somewhere that it's 100 databases and 10 AGs, so 1,000 databases on the instance total. But Azure Managed Instance does enforce a 100 database limit. So if you use MI, you can have up to 100 databases per managed instance. And then after that, you need a new managed instance. If you care about high availability and those failovers, I would say that 100 databases should be your absolute maximum. You can test it. In testing, you might find that you can push that a little further. You might find that you need to pull back a little bit. But a generic statement, I would say 100 databases per AG. And if you do testing and do thorough testing, you might be able to go a little bit in either direction. But it's going to be closer to 100 than 32,000. Okay, now I have another story. I think this one's Taryn's favorite, probably, even though it happened after she left.
I did laugh.
Yeah. Yeah, I'm sure you did. So like disruptive DML, DDL changes in an AG, right? We failed over, we did the thing that Aaron mentioned for maintenance, where we moved to Colorado for like half an hour for me to do some of these schema changes. So let's think about how this happens. We make a change, it's written to the transaction log on the primary and secondary. If you are using synchronous commit, which we're not, but if you are using synchronous commit, that change, whether it's DML or DDL, it gets written to the transaction log on the synchronous replicas before it's considered committed on primary. The data is changed on primary as part of that script, just like normal. You know, it goes to the log, it happens to the data in memory, your transaction is done. On secondary, the redo part is always done asynchronously, even if you're using synchronous replicas. It's not synchronous change happening on both, it's synchronous writing to the transaction log. After it's written to the transaction log, all of the secondaries pick that up and redo it. If you're querying a readable secondary, readable secondaries force the use of snapshots so that reads don't block writes. But if you're making a schema change, it still has to take blocking locks. In order to change a table definition, you can't have people actively querying it. So let's talk about the time I broke Stack Overflow.com. During the maintenance window, we had it in read-only. We're running out of our DR location in secondary. Great, I can make these disruptive changes, except I've kind of given it away. So specifically, we're removing sparse columns. These were, again, kind of dating back to a decade ago when we were being really frugal with our hardware and our storage. Sparse columns were used for columns that are frequently null. Nowadays, row compression is a much better answer for that. Anyway, but we also have plenty of disk, so we don't have to worry about using sparse columns. Sparse columns, one of the reasons why we were proactively removing these sparse columns is sparse columns on very large tables prevent online DDL operations. So an online add column, which is great normally, adding a column doesn't cause blocking. Exactly what we want to avoid. So we have to remove the sparse columns for that to happen. When the redo started to happen on secondary, everyone was blocked. I had this perfect plan. I would make the change on primary while we ran out of our DR location. Nothing would go wrong. After we made all of those changes, we would fail back and I wouldn't have caused blocking and wouldn't have taken the site down, except that I did. And we were removing a bunch of columns. So the first column I removed, stackoverflow.com went down. In the middle of the maintenance window, we altered our approach. On the readable secondary where we were running the site, altered database, set HADR suspend. Now it stops redoing all of those logs. It's like paused in the AG. The stuff I do on primary is going to queue up and not be sent to secondary. So I made my change after I suspended change on the secondary. And that means that I'm writing to the transaction log on primary, but it's not going to Colorado. It's not being redone in Colorado. I'm not going to break production again. Then after I made all of my changes, moved traffic back to primary, came out of read-only, made sure everything was happy. And then I resume HADR, set HADR resume. And that now after we're off of that server and we aren't actively using it, it sends across all of those disruptive changes. And again, this is something that really works because of the way we've built our architecture, where we can use DR for real anytime we need it to serve read-only traffic. Okay, that was the end of my story. And my mouth is super dry because I was either talking really fast or I'm super nervous. We'll find out later.
So we've got a couple questions to get into. One from Q&A in Zoom and one from Slack. So the one from Q&A in Zoom, somebody pointed out that they found with more than 150 databases, the latency within the AG got too high. So they generally end up settling around 100, 102 per AG. And we're curious for the thoughts of you folks about, is there kind of a magic number where the latency seems to tail off? Or is that just is that not just dependent on number, but a whole lot of other factors?
It's definitely dependent on other factors. One of those factors, I'm going to stop my screen share here so I can look at everyone's sunshiny faces. It's more a factor of how busy databases are. So with us running 380 databases in one AG, we don't actually see a lot of latency because the change volume is relatively low, or at least relative to this person that's running 150 databases. But there are a limited number of threads that get used for sending. So in the case of having high volume data churn, breaking up some of that to move some of the busier databases out so they're not, all of the busy databases aren't in one AG, can definitely help the send performance on that. I don't know the exact internal details on how that works. Alan Hurt is in the Slack channel. I'm sure he will correct me on any details I say, but.
So let me thank you up front for that perfect segue, because I was about to relay a question from Alan, and I'll read it verbatim. It says, one interesting thing I would love to hear, how do you size, scale, configure your TempDB for your porta potty? I find customers do this poorly. Don't have a clue since a read-only replica is not exactly the same as a readable DB and how it works. I would love to hear your approach, and that is for the group.
You want to start, Karen, since
because y'all probably have made changes, so that is on your plate. I don't have access to the infrastructure any longer, so it's up to you guys.
The one change we did make, Aaron made. So maybe Aaron will start and talk about the TempDB in-memory TempDB.
So we did enable the in-memory TempDB configuration option on all of our servers, and then we turned it off on a couple because we were getting stack dumps that still haven't been analyzed by Microsoft, and that there is still not a CU fix for. Microsoft has acknowledged that it's a problem, and they just don't have a fix yet. So we were getting disruptive stack dump behavior on a couple of servers with very specific workload types, and that setting was not helpful in those cases. So I hate when we have a setting that we can apply on most of our servers and not a couple, and we have these exceptions, and that kind of sucks. But that's where we're at right now. We don't know of a timeline from a fix from MS. Karen, you're supposed to change your background, I think.
My bad. I sorry.
I'm not trying to badmouth Microsoft. I'm sure it's a complicated problem, and I'm sure there isn't a fix yet for a reason. It's been known for at least for a couple of CUs so far. They've known about it, so I'm not sure. But,
yeah,
got it.
To go back to Alan's original question, though, we don't do the OLTP website workload doesn't make heavy use of TempDB, so we don't necessarily do anything super special for TempDB on these servers. We follow general guidance roughly, but since utilization on TempDB is pretty low, we don't have to worry about it too much.
Got it. Yeah. Well, it was interesting to hear the development refinements, because a lot of times developers will just lean on TempDB to, as that scratch pad, right? And it sounds like obviously Stack's done a lot of work over the years to not do that, which the DBA part of my brain appreciates very much. So we've got 3 questions that have just come in Zoom. Well, one just disappeared, so never mind. So we're down to 2. One is, would you recommend suspending HADR on secondary when applying CU patches and failing over so you wouldn't experience issues on the primary?
No, I don't bother. I do switch to async while if I'm going to be doing planned maintenance and plan a restart of the service. I'll make sure that node is switched to asynchronous commit before I start doing restarts. But other than that, it's no problem. And since we run an async as standard operating procedure, we don't have to make that change at all.
Got it. Makes sense. We've got another one here in Zoom. It says, do you re-index your large tables regularly, and do you notice any impact to your AG secondaries?
I'm going to take that one.
Rock and roll.
I will take that one. So we used to. I can't speak to whether Andy and Aaron do. My guess is probably not, unless they have to do it ad hoc. I used to have a job that did index maintenance weekly. I took the server down. Remember how I said that we had limited drive space and limited infrastructure? We ran out of drive space during an index maintenance job. I completely maxed out. We were at 100% disk utilization. It was completely gone. So we had a very severe outage on Mother's Day. I remember the day, and I had just started the job. So no, that job got turned off because of those issues that we had with free space. We did periodically do index maintenance if we needed to rebuild an index. Sometimes we would do that. But yes, you do have implications when it comes to the secondary with that, because for one, there's like log issues. You've got to write all of that. So there's some additional issues if you're doing index maintenance. I wouldn't normally do that any longer. I'm sure Aaron and Andy don't do it unless they absolutely have to do it. We always had some databases and some tables that had to have some hand holding. I don't know if they're still doing any of that. I will let them comment on that. But yes, you have to be very careful.
Yeah, we do not rebuild any indexes at any point in time. We do have a job that runs on Sundays that updates statistics with full scan on our very large tables, and the tables that have that are known to cause plan skew because there's data skew, and we get crappy plans if statistics are out of. Actually, we get crappy plans when there are auto statistics specifically. So for those tables, we update stats weekly, and we also have auto statistics turned off on them. Which brings me to another problem that we have noticed on our AG, which is temporary stats on secondaries. Even when there are real statistics that are up to date and not stale in the database, the secondary will sometimes trigger auto stats, and the secondary will have temporary auto statistics, which then cause read-only queries on secondary to go sideways. So that was fun. But yeah, as a general rule, we do not rebuild indexes. I would rebuild an index if we dropped some big columns, some wide columns, and thought that we could reclaim space, significant amount of space, maybe. But for the most part, in the days of modern fast SSDs, statistics are probably 10 times more important than rebuilding your indexes. Maybe more than 10 times.
So I'm going to throw a bit of a curveball, because it seemed like a lot of the undercurrent here was understanding your workload, which is obviously really important. And you mentioned some tools, obviously, that get you in much better touch with that. For folks that don't have those, that are relying more on gut feel, if you're trying to get out of gut feel into, I at least have some information in front of me, what would the three of you recommend?
I'm going to recommend my DBA database. If you download it from GitHub and install it according to package directions. It will also, there's two scripts that you run. So you download my script and there's PowerShell script in there that will grab who is active, the first responder kit, and Eric Darling's stuff, and Ola Hallengren's stuff. And it'll install all of that in the DBA database. And that is the set of all of those open source tools, all those open source scripts, give you a lot of stuff.
Yeah.
Yes, but
Go ahead,
Ozar's Blitz stuff too would be useful to have. And Opserver is open source, so if the limitation is, hey, we don't have money to spend on commercial vendor tools,
right?
I do think there are a lot of options that maybe aren't, flip a switch and then suddenly it's working. Opserver you have to configure and all of that. But there are certainly open source tools that are not, where cost is not the barrier.
Yeah, it's more that bridge between, oh goodness, I have no idea what to do. I don't know what I'm looking at. I'm basing this all off gut feel. And yeah, that bridge to at least, productionize open source tools and then stuff you pay for after that. Andy, could you drop that link in Slack? Because that would, I think folks would find that very helpful.
Earlier.
I'm happy to drop it again.
More information is not bad. Just had another one that came in on Zoom. I know we're creeping up on time here. Said not use distributed AGs before, not DAGs. You're welcome, Alan. Any gotchas or advice for a newbie to these?
I have a couple.
Yeah, go ahead, Taryn.
So for one, there's not a whole lot of tooling around it, which makes it difficult. That's one thing. The second thing that I would say is know your latency between your primary AGs and everything between all of the distributed AGs. So we had a very long run of an issue between the Colorado data center and the New York data center. And when I say issue, it was like going on 2.5 years. We had a latency problem between the two. And when you have a distributed AG and you have the Stack Overflow database that needs to replicate to our reporting cluster, which then has to replicate to the Colorado server and then the node in Colorado, and we had a latency issue. One thing that we always would have is the log on the primary for Stack Overflow wasn't truncating because the log hadn't fully flushed throughout the distributed AG. So that is something that you need to kind of pay attention to. And again, it comes down to the fact that we had limited infrastructure. So hard drive space was always something that we were worried about. So monitoring like the logs and the latency between your environments is very critical. And there's not a lot of tooling built in for distributed AGs. So Opserver, I mentioned in chat, I lived in it because it shows in Opserver what the log sizes are. So I could monitor and I knew what the normal log was for Stack Overflow or for any of the sites. So those are things that you kind of need to kind of pay attention to. And those are some gotchas that I have. I don't know if Andy and Aaron have others.
Yeah, I was going to say the same thing, but the lack of tooling. Taryn, close your ears, pretend you're not here. The lack of tooling is a huge problem. Like you just have to, everything's T-SQL or PowerShell for distributed AGs. So you have to be really comfortable with that stuff. I wish that there was a semblance of tooling, that they would at least pretend to have something for tooling for distributed AGs. So that's a barrier. It's not a starter feature. It's definitely a pro feature. And then I also reiterating what Taryn said on network latency. Having a solid network between nodes is a requirement for any AG, including a distributed AG. If you have latency, jitter, bandwidth, reliability issues, all of those things can affect your ability to sync across the distributed AG.
Those are all good tips. I don't see, as of right now, any questions left. So I think we technically have 2 minutes left. Are there words of wisdom that you'd like to pass along that you haven't yet?
I see one question. Someone asked where I got the Darling Data shirts.
Oh, right. Yes.
Max.8. Or what do I have? Max.0? No, I have Max.8. There's Max.8 and Max.0 shirts. They are not for sale as far as I know. I think you have to do a favor for Eric and get one. I don't exactly remember. I think Karen and Aaron both have one too, right?
I have a
don't
Max Stop Zero because I'm team Max Stop Zero.
I don't have one, but I've heard that if you compliment his tattoos, he may send you one.
That's how my husband Ken got his Darling Data shirt. He complimented Eric's tattoos.
Well, those are certainly words of wisdom.
Comment from in the Q&A, SharePoint, Max Stop 1. There are no Max Stop 1 shirts available from Darling Data.
SharePoint. Well, we could probably have a whole session on SQL Server in that, couldn't we?
Yeah, I mean, we definitely need to, that would definitely need to be something where we make sure that everyone has their calming liquid of choice, whether it's hot tea or a keg of bourbon.
Yeah, it's interesting to me. There's been some chat here in Slack about distributed AGs and, is the tooling going to come along for the party? It's used under the covers in managed instances. So it's interesting to me that, there's not tooling because there are scenarios where they're useful for, but, everything Alan and other folks have said here is spot on. If T-SQL and PowerShell management scare you, don't do them because that's how it has to work.
I just wanted to add something really quickly before they break off this part of the recording, and that's Alan Hurt's comment in the Slack that says, "Let's be clear, Andy's answer is spot on. Know your workloads." And then he added, "Andy's good." So I just wanted it to be part of the recording.
There you go.
You just wanted me to blush on camera?
You don't blush.
Duly noted. I see Aaron's so I was going to say, somebody just popped in and said, are you using Windows Core Edition? Aaron just answered that. So for audio posterity's sake, would you like to comment on that before we switch over here?
On Windows Core?
Yeah.
I don't know of a single server where we've installed Windows Core.
I've actually never run into a Windows Core installation in the wild in my experience.
Yeah, I understand the benefit of it. I'm not saying it's a bad thing to have, just I haven't come across an org yet that has deemed the benefits worth not being able to RDP and interact with it like all of the Windows machines you've worked with your entire career.
And as someone who's not a consultant, I admittedly run into fewer environments in the wild than some other folks. So it's not like me saying I've never run into them is saying that they're not in use, or that they're rarely used, but just that even at companies like Wayfair and Stack Overflow, we just use good old fashioned Windows with desktop experience.
Yeah, so it looks like we've got John Morehouse in Slack who said he does have a client runs Core. Some other folks noted that they have seen it or have had clients that did or they did, and the regret seemed to follow shortly thereafter. There is a compliment in the Q&A panel. Great session, great details for real life use of AGs. Thanks a lot for this. So well done, everybody. There's another one that says, are you set favor background app for SQL? Not sure what we're getting at there, to be honest.
I think that's the configuration in the server, favor background services instead of foreground application. I have no idea, but we don't have any applications that would apply to that are running on our servers. So I don't know that it would really change anything on any of our SQL Server boxes.
All right. This is not AG related. So as we're switching over, because I think the next section starts at 3 Eastern, which is 7 UTC, if my math brain is working right.
Yeah, we have about 12 minutes to the next session, so we're all good to keep chatting for a while.
All right. So this is a nice generic one. What SQL Server 2022 feature do you expect to help you or anybody? I'll add to that the most.
Aaron, do you have to think about it?
Not everybody at once. Come on.
Well, I mean, we are talking about eventually going to managed services in Azure. So at some point, the ability to fail over to a managed instance and fail back to on-prem is going to be pretty important to us. But I mean, that won't be for a while. So not something that, you know, as soon as we start using 2022, we'll be able to use that. That's more down the road.
Yeah, that's the same one I was thinking of. I was thinking of MI Link, Managed Instance Link, they're calling it. That'll let you fail over and fail back from managed instance. Because if you're going from beefy on-prem hardware to the cloud, you might not get all of your performance sized correctly. So I love having a failback plan when I do stuff. The other thing that I'm really excited about is contained availability groups, because all of this, like my entire career, I've spent 20 years with nonsense about copying logins from your primary server to your secondary server, and just all the other stuff that's stored in MSDB that you end up master in MSDB that you end up having to copy across. The idea of AGs being able to help you with that makes me excited.
But you already have jobs that sync everything, Andy. I mean, come on.
We do have jobs that sync everything, and they no longer cause us any problems. But
Let's say there are at least two of us on the screen right now that have slides that talk about this, probably more that I just haven't seen. But yeah, it will be helpful because, I mean, speaking from my experience, it was an easy step to miss. I have a whole part of a presentation about missing that because you just don't think of it. You're like, oh, we set up this thing. It's really cool. It just came out. Oh, right. We can't log into anything, and none of our jobs magically went over there. So easing that on-ramp into AGs does strike me as a useful thing. Certainly would have saved me a couple stressful phone calls over the years.
Yeah, and like if you have a job that you create, even if your sync job runs daily or every hour, you run the risk of having made a change that doesn't get synced across when your job runs next. So
yeah, that's all true. I see the display has been taken over. So
sorry, I grabbed it just to get the feedback slide up, just to tell all the attendees that